Hello, our most developed student. My name is Confident and welcome to our 24-minute lesson. This is the ultimate guide in maths, science, career guidance, as well as a sneak peek in my personal experiences. This is a channel that is designed with you in mind. Let us dive into today's lesson. Hello once again, our most developed student. My name is Confident and welcome to our revision session, the ultimate guide in your revision for grade 9, and it's for you guys who are doing your term 1 work. And in this lesson I'm looking at law number 2. In the previous lesson we looked at law 1, which involved the multiplication and the addition on exponents, but now we're looking at division. It's the division in this case. So if you didn't grab hold of the first lesson, it means you are missing out. Go to the previous lesson to be able to understand this. Now, what does it say? It says, ensure bases are the same for the law to work. Look at the base. Look at the base. Just look at this. A to the power m divided by a to the power n. Look at this. There is a. There is a. There must always be the same base. Now, what do you do to your exponents? You subtract them. M minus n. So if you see the division line, see there is a minus inside division. So I always say to students, if you are given a multiplication, you can see that if I can twist this multiplication, let me see, it will allow me. If I can twist this, see, twist that and take that one, and I also twist it like this. Just want to twist it instead. Look, the multiplication became what? Became a plus. So that's why I'm saying, if it was in this case a to the power m times a to the power n is equal to, you twist it around, it will give you a to the power m. There is the plus n. So this plus is the twisted version of the multiplication. So that is simpler. But now with the minus, you see the division has got a negative. There is your negative also. But this law is in two parts. You can also be given it. Remember the word division. You can say, a to the power m. If I say 2 divided by 4, this is same as saying 2 over 4. That's 2 divided by 4. So that's why here, if you say a to the power m divided by a to the power n, hence you can change it into this sign. It still means the same. If it's a division and it's at the bottom, it will be a to the power m minus n. Don't forget that. Now let's look at this example here. They are saying you are supposed to simplify 2 to the power 5 without a calculator divided by 2 to the power of 2. If you're doing it the long method, remember 2 to the power 5, it's 2 times 2 times 2 times 2 times 2. How many times? 5 times. I told you the word divided means over. 2 squared, it's 2 times 2. So in a way, this is same as 2 to the power 5 over 2 to the power 2. Then you get to that stage. Then at this moment, you are able to cancel 2 cancels 2, 2 cancels 2, and what remains? This is 2 times 2 times 2. By the way, guys, don't say nothing remains. It's 1. It's 1 there. It's 1 at the bottom. 1. 2 into 2, 1. 2 into another 2, 1. So you get 1, 1, 1, 1, 1. So in a way, I'm having something like this at the top. I'm having 1 times 1 times 2 times 2 times 2. Usually we leave out this 1 because it changes nothing, you see. And then divided by 1 times 1. Again, divided by 1, it changes nothing. Hence the answer simply becomes 2 times 2 times 2. And 2 times 2, 4, 4 times 2, it's 8. We can say actually this is 2 to the power of 3, and 2 to the power of 3 is 8. Now, using the laws of exponents, I was going to say 2 to the power of 5 divided by 2 to the power of 2. Now my bases are the same. I know with division it's subtraction, which is 5 minus 2, which is equal to 5 minus 2 is 2 to the power of 3, and 2 to the power of 3 is equal to 8. Now it sounds simpler, but suppose you are given numbers like this: 2 to the power of 100 divided by 2 to the power of 50. You can't be multiplying this 100 times and this 50. You can't say 2 times 2 times 2 times 2 50 times. You'll get tired. On top 100 times, you'll get tired. You just apply the law. So in the case of this one, whereby it was 2 to the power of 100 divided by 2 to the power of 50 is the law, equal to same base, 2 to the power of 100 minus 50, which is equal to 2 to the power of 50. You leave the answer like that. Are you with me? So that's how you solve that. Now let's look at this example here. I think there is a little bit of work here. It says simplify the following using laws of exponents. Now let's look at this. If we're given in this case 2 to the power m squared n times 7m squared n5 over 14 m cubed n times 18m over 6n. I'm supposed to simplify this. Now for me to be able to simplify this, and they say use the laws of exponents. So you can check with your calculator and everything, but you can try something here. You need to know a few things. For example, 7 divided by 7 into 14 is that. Or you can express everything as a product of prime factors, meaning you take 14, you say 14 equal to shift fact, it will give you 2 times 7. You take 18, you say shift fact, I think it will give you 3 times 3, it will give you 2 times 3 times 3. 18 will give you that. And you take 6, it will give you 2 times 3. These are product of prime factors, right? So I can write this further as this is equal to 2, you can put times in, m squared times n times 7 times m squared times n to the power 5 all over. So we put it times more like in the center here. I don't want it to confuse. So which means this one I can put it a little bit high. Okay. So that my times is straight. And then 14 I say it is 2 times 7 times m cubed times n. See? Times 18 is what? 2 times 3 times 3 times m over 2 times 3 times n. I need this m to be visible, so it's times m. In a way, that's what you be splitting this thing into. But now look at this. Now the fact that here it look like it is straight. Look at this one. It looks like this is straight. You can't tell whether it's on top or it's at the bottom. But the thing is, always know it is always at the top. So you can literally do this. Put it on top. You allow, say over 1. All numbers are over 1. And now at that stage, you are able then to do a few things that cancel out. For example, the 7 cancels the 7. The 2 cancels the 2. The 2 here, remember I said when you're cancelling it's 1, 1. 7 is 1, 7 is 1. 2 there it's 1, 2 there it's 1. 3 there it's 1. And 3 there is 1. Then you write what is remaining. What do you see? On top, write everything remaining. M squared times n over 1 times m squared times n to the power 5 over m to the power of 3 times n times 3 times m over, you see, 1 times n, which is n. Now when you do that, you can now apply the laws on top. Now focus on m, collect all the m. It's m squared times m squared. So we're done there, there is another m times m, because everything is multiplying. And then you follow with n, there is the n, and then there is another n. Remember, it's using the laws of exponents, over m cubed, there is a 1 there, so we leave it, times n times n, n times n, you see, equal to, now same base, it's m, so you say m, apply the law, you are multiplying, it's 2 plus what do you put there? You tell me. When there is no power, it's a default what? 1, remember, times n, again n, there's no power, default 1, which is 1 plus 5. Are you following up? Over m to the power of 3 times n. Look at the bottom n. There is no power means there is a 1 and a 1 that is hidden. That's what you simply do. And then when you continue taking this thing, it will continue now to say 2 plus 2, 4 plus 1, 5. It's m to the power 5 times n to the power 6. At the bottom, it's m to the power of 3 times n, 1 plus 1, it's 2. We continue. Now, see, at the top is multiplying. You can't do anything between m and n. Don't be tempted now to do this, to say equal to m times n. You remember this thing? 5 plus 6 over m times n and 3 plus 2. No. What law are you using? There is no such law. Please, there is no such law. This is a big no. This is a big error. Alright, what are you supposed to do? You're supposed to follow the rules, and the rule is saying if you are given a scenario like this, you continue applying the law. So in a way, you are saying here it's m, look, m5, m to the exponent 5 divided. Remember that law which says a to the power of m over a to the power of n is equal to a to the power of m minus n. That division is the same thing. There is the division line. So what do you see? You are seeing here m to the power of 5, that division means minus 3 times n to the power of 6, the bottom one, n becomes minus 2. Do you see what happened? For this one, for the division, each one has a division. Okay, so it's also fine to say this thing was m5 over m3 times n6 over n2, so that it follows this part. Are you with me? Then you have got m5 minus 3, it's 2, n6 minus 2, it's 4. That becomes the final answer. You can drop out the multiplication sign. Is it making sense? It's very important, guys, for you to be able to do that. But I'm getting different answer here. They gave me a 3. I'll check how the 3 came about. But I think whatever case is 3 squared. I think I also lost a 3 somewhere. Let's check this 3. Yes, I see it now. I lost this 3. That is wrong of me. It's m. See, m squared is that, m squared is that, and m is that, and then n is that, and n5 is that. See now, I forgot that. So I was supposed to say, actually even start with it 3 times. So there was supposed to be a 3 in everything here, times 3 equal to, so we multiplied, 3 was appearing in everything here. So 3, so the answer became 3m squared n to the power 4. Are you with me? Now, I hope you picked up that error also, but let's finalize this work. Look at this. It says activity, simplify the following using laws of exponents. Can you try that? Let's start with A. Can you try that for me? What do you think will be the answer? They are saying x to the power of 2 divided by x to the power of 8. What do you think? Now you apply the law. Same base, x on top, x at the bottom. So you subtract, the top one is 2 minus the bottom one is 8. This is same as saying x to the power of 2, that division line is divided by x to the power of 8. See that? This is the same thing, which is equal to, use a calculator here, 2 minus 8 is what? The bigger number is negative, is x to the power negative 6. Are you with me? So that is that. What about this one here? What you need to do with this one here, which symbol says 2 times, I prefer to put times, a to the power of 3 times b times 8 times a to the power of 4 times b to the power of 3 all over 32 times a to the power of 6 times b to the power of 6. What do you think, or what will be the answer? Try to solve it in simple steps without making a lot of working. What do you think? First of all, you need to convert these numbers. Like 2 is already done, but you can convert 8. Remember this, 8 is equal to what? 2 times 2 times 2, which is 2 to the power of 3. And 32, you use a calculator, you say shift 32, you start with 32 is equal to, then after that you say shift effect, it will give you 2 to the power of 5. Are you with me? So what you have here then, you have got 2 times a to the power of 3. Okay, let's collect like terms already. 8, remember 8 goes to meet there, it doesn't jump sign, you are just rearranging. So 8 is 2 to the power of 3. So you've got 2 to the power of 3 for this 8, and then we're done. Now follow with a to the power of 3, rearrange this other one also, bring it closer, it's a to the power of 4. Do you see what I'm doing? Times b to the power of 3. I'm rearranging according to like terms. 32, we say it is 2 to the power of 5 times a to the power of 6 times b to the power of 6. If we continue, now multiplication, what do? You add the top. So look at this, there is a hidden one there. So it's 2 to the power 1 plus 3, are you with me? Times a to the power, same base there, is 3 plus 4 times b to the power what? What's the power for b there? It's hidden. It's also 1 plus 3. Are you with me? Over 2 to the power 5 times a to the power of 6 times b to the power of 6. Are you with me? Now we continue with this. Now 2 to the power 1 plus 3, it's 2 to the power 4 times a to the power 3 plus 4, it's 7 times b to the power 1 plus 3, it's 4 all over 2 to the power 5 times a to the power 6 times b to the power 6. Now as I say to you, I'm gonna write it away from here. Everything is multiplying. It's same as saying 2 to the power 4 over 2 to the power 5 times a to the power 7 over a to the power 6 times b to the power 4 over b to the power 6. It's the same, but you can leave out this, but it's the same. You can even put it in as the next stage, but what I'm trying to say, that's where you can apply now this rule. What does the rule say? A to the power m over a to the power n is equal to a to the power m minus n. Remember that rule. That's what we want to apply now. But we are using 2 for the first, so it's 2 to the power of 4 minus 5 because of the division line, and then times a to the power of 7 minus 6. There is no more. The moment you apply the law, the bottom one disappears now. There is no more over, and then b to the power of 4 minus 6. Use your calculator now. 4 minus 5 is 2 to the power minus 1. Just punch that calculator. Times a to the power 7 minus 6 is a to the power 1. B to the power 4 minus 6 is negative 2. But I want you to use that calculator. The final answer will be 2 to the power negative 1 a b to the power negative 2. For now, let's leave it like this, because we haven't done other laws where you can further express that and express that, but let's end it up here. All right, so that is that, guys, as we are working on these. Now let's look at the other ones, because I think this activity has quite a few problems here. Let me look at C. Yes, there is C. C is saying what? Look at C. X to the power 5 times over x to the power 2 times, look at the times is written straight here, times x to the power of 3. What do you do? Apply the law there, which is what? Division. See the division? It's x to the power 5 minus 2. Do you see the law there? That's what I've just used, is the law. Same thing we did here, x squared over 8, we subtracted there. This is similar to that, see that? But don't forget, we still have this one, times x to the power of 3, which is equal to x to the power of 5 minus what? 5 minus 2, it's 3 times x to the power of 3. Again, it's not done. Same base, multiplying. What do you do with the multiplication? Remember the law, a to the power m times a to the power n. What do you do? A m plus n. Same thing here, x3 plus 3. The answer then becomes x to the power of what? Of 6. Are you with me? Just take it easy, one step at a time. Look at this one. Also not complicated, but you need to be very sensitive. Look at this D. They are saying here, you are simplifying what? Let me write it so that it's clear. This is 2010 times 2 to the power 2020. Even your calculator can simplify this. It will say error because the numbers are too big. See? So start with the top, same base. What do? You add it. So it will be 2 to the power 2010 plus 2020 over 2 to the power 2015. I think that, which is equal to, now we add 2010 plus 2020. I think you need a calculator now. Just add 2010 plus 2020 equal to 4030. It is 2 to the power 4030 over 2 to the power 2015 equal to, now same base, division, you know what to do, 2 to the power 4030. Because it's division, now it's minus 2015. Are you seeing that? Because you have to subtract. Why? Because it was the division at the bottom. So you say 4030 minus 2015 equal to 2015. So your answer becomes 2 to the power 2015. That's it. You don't have to force it. You don't have to worry about this. You just have to simplify that. Someone can come here even and do this. Just playing with you now. Look at this. You know that this has got 2015. So I can say 2 to the power 2010 times 2 to the power, look, 2015 plus 5 over 2 to the power 2015. I'm matching it at the bottom. Remember, 2015 plus 5 is 2020. So I can come and say 2 to the power 2010 times 2 to the power 2015. Now if it's plus, I say times 2 to the power 5. The first law. Remember, a to the power m plus n is also equal to a to the power m times a to the power n. I'm reading it the other way around. You are used going this direction, but I'm reading it the other way around. Over 2 to the power 2015. So when you see this, cancel that. You are left with on top 2 to the power 2010 times 2 to the power 5. You add now 2 to the power 2010 plus 5, which is 2 to the power 2015. The answer that you just got. Okay. So these are different ways you can get your answer, but the first one, I will advise the first one. Alright, so with that, let's simplify the last one, which is what? The last one, because of my time, just bear with me. 3x squared times 4xy to the power z over 2x what? 2x squared, right, y times 6x squared times y to the power of 9. Different approaches, but at the end of the day, the aim is to ensure that the answer is the same. If everything is multiplying, you are also allowed to do this, just to get rid of some of the things. You are allowed to say x squared can cancel x squared. Then you say equal to 3 times, now 4, you express it as a product of prime factors. 4 will become 2 to the power of 2, but you can say 2 times 2 if you want. Why? You can actually do this here. You say 2 into 2, 1, 2 into 4, it's 2. I think they will allow that. And then you can say 3 into 3, 1, 3 into 6, it's 2. And then this 2 cancels the 2. So all the numbers in a way they're cancelling. It's actually 3 times 4, which is 12, 2 times 6, which is 12. Now what are you left? You are left with on top, look at this. Anything you never cancelled is that one. X times, you put a times y to the power of 7 over x squared times y to the power of 9. You see that? Now individually, it's same as saying x over x squared times y 7 exponent 7 over y to the exponent 9. That's what it simple means, whereby I can apply the law now and say x. Now there is a hidden 1 there. It's 1 at the bottom is minus 2, since it's coming from the bottom and there is a division. And then times y to the power of 7, again here it's minus 9. You don't have to repeat the y, just put the exponent of it. So x to the power 1 minus 2, use a calculator, is minus 1. Y to the power 7 minus 9 is minus 2. That becomes the final answer. So guys, this is what I wanted to bring to you at the moment. The law number 2, where it's on division. In the next exam, in the next lesson, we're going to look at the zero exponent rule and its proof, and continue also with other laws that are very, very important that you can't afford to miss. Join me in the next lesson. Thank you.